This is lesson 1.4, solving absolute value equations. So first we need to recall what absolute value actually means. And the number line illustrates this best because the absolute value of a -4 and the absolute value of a +4 is +4 units. So what this means, if you look at the number line, -4 and +4 are both 4 units away from 0. And the distance is always a positive number. So that's what absolute value means. It is the distance from 0. And I'll put in parentheses, it's always going to be a positive number because distance is always positive. You can't take a ruler and say this is like -2 centimeters. So distance is always positive. So example 1, evaluate the expression that has absolute value with it. So we're going to follow the order of operations, but also apply absolute value. So 8.4 minus the straight absolute value bars, 2 times n, which was -7.5, plus a 5, close the absolute value. So we're going to do what's inside the absolute value first. So this is going to be 2 times -7.5 is -15. Again, you're going to simplify what's inside until you get to one number inside the bars. So -15 plus 5 is a -10. Now the absolute value of -10 is 10 units away from 0. So when I figure that out, we drop the absolute value bars at that point. And 8.4 minus 10 is -1.6. Some students think that absolute value means taking the opposite. So if you had they think the absolute value of a +4 would be a -4, which isn't true. So the absolute value is always, 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 always positive. All right, so here's a real-life application. We have a tennis racket that has a 100 square inch head on it, plus or minus 20 square inches. Write and solve an absolute value equation to determine the least and greatest possible sizes for this tennis racket. So you could obviously solve this just by problem solving, all right? If the standard racket has 100 square inches, give or take, or plus or minus 20, you should be able to figure that out. So 100 is the standard size, and if you add 20 to that, you're going to get 120. But if you subtract 20, you're going to get 80. So the range is either 20 below, which the least size would be 80 square inches, or the highest, greatest possible size would be 120. Now it does want an absolute value equation though, so it's always going to have the absolute value of some number, subtract, and here's the tricky part. Where does the 100 go? Where does the 20 go? So think of the 20, the plus or minus part, as moving left or right on the number line. So that's like the distance. So that's going to go what it's equal to, the plus or minus 20. The target number is what's inside the bars. So x minus 100. And if we solve this, we have to do two cases. So x minus 100 equals 20. So I would add 100. And that's how I got one of the answers, being 120. The other option is taking x minus 100 equals -20. So again, you add 100 to -20, you get the second answer was 80. Now, when you're solving an absolute value equation, like the two examples underneath, 2a and 2b, solve each and check them. There are two cases that you have to consider. So consider moving left on the number line, consider moving right on the number line. And this is the part that students only do case 1 because they are in equation solving mode and only think about doing 1. and then always forget to do case 2. So that's a common mistake. So the absolute value of x plus 12 equals a positive 9. So realistically, you're thinking of what two numbers could be inside to give you a 9. Well, you should know those two answers are either a positive 9 or a negative 9. The absolute value of a positive 9 or negative 9 is a positive 9 distance. So we're going to set what's inside here, the x plus 12. Case 1 would be setting it equal to a positive 9. And case 2, the x plus 12, I'm trying to think about what x value makes that into a negative 9. So the only parts that change on case 2 are what it's equal to. On the left, it's still x plus 12. On the right, we're seeing what gives us a 9, what gives us a negative 9. So these are nice and easy. Subtract 12. X is negative 3. That's one solution. And if I subtract 12 on case 2, you get x is negative 21. So think about it. If you put that back in for x, negative 3 plus 12 is a positive 9. The absolute value of positive 9 is 9 units away, so that checks out. Negative 21 plus 12 is going to give you a negative 9, and the absolute value of negative 9 is positive 9. So always go back to the original problem at the top. So those should be our answers. And they wrote it not really as an ordered pair, but you can just leave it as x equals negative 3 and x equals negative 21. So example 2b, similar thing. You want to know what value inside the bars would give you a positive 8 and a negative 8. So case 1 is dropping the absolute value bars and setting it equal to positive 8. Case 2, setting the y plus 5 equal to a negative 8, and you're going to solve them in the same way. Subtract 5, one answer is y equals 3. Subtract 5, the second answer is y equals negative 13. So those are your two solutions for this problem. So absolute value is always going to have two solutions, going left, going right. Now, here's the exception. Because the absolute value of a number is always positive, or I guess it could be 0 if it's 0, an equation like the absolute value of x equals negative 4 is never true. Thus, it has no solution. The solution set for this type of equation is called the empty set. We can have braces with nothing in it, or the circle with the slash through it. Those are our notations. All right, so if we're solving this first one, the absolute value of 3x minus 2, and then you're adding 8, and I want that equal to 1. So first you want to try to get your absolute value part completely alone first. So make a little side note. Want to get the absolute value alone first. So I'm going to just subtract the 8 over. So it's going to turn this into the absolute value of 3x minus 2 is equal to a negative 7. Well, this should ring a bell because the answer over here is a negative number, and you can't have a negative distance. So this one has no solution. So circle through a slash, or you can write no solution. So you got to be cautious with that one. Some students will not even phase them that that's negative and start doing case 1, possibly case 2, but their answers aren't going to check out because you can't take the absolute value of a number and get a negative distance. The one underneath, similar concept. To get the absolute value bars alone, you have to get rid of the multiplying by negative 2 in the front. So you're going to divide both sides by a negative 2 and get the absolute value of 3a is equal to a negative 3. Again, this one's going to have no solution because you can't have the absolute value be a negative. So that one also has no solution. And I'm not going to go through all of these practice problems because I want to keep the video fairly short, but I'll do number 4. Seems like it's the hardest out of 1 through 4 here. So -2, the absolute value bar, 3 times x, which is -4, plus 8, another bar, subtract 4. So we're just going to evaluate this. This is going to be -2, the absolute value bar. This is -12 plus 8 inside. Again, you have to figure out what -12 plus 8 is, and that is a -4. Let me move this fish. Well, I guess I can't move that down. Let's go over here. So -2, the absolute value of a -4 minus a 4. So the absolute value of a -4 turns into a +4, and we can put that in parentheses because we're going to be multiplying these, which is -8 minus 4, and that equals a -12. The other ones are pretty easy, so I'm not going to show you those ones. Let's just talk about this fish tank question real quick. So most freshwater tropical fish thrive in water that's within 2 degrees of 78 degrees Fahrenheit. So this is like the tennis question. Excuse me. Write an equation to determine the least and greatest optimal temperatures. Solve the equation you wrote in part A. So we can kind of do that without the absolute value equations, but let's practice. So within 2 degrees, that is your distance. So that's going to be what it's equal to, plus or minus 2. And inside is the target temperature, x minus 78. So that's the equation. Part B says to solve those. So remember, we need 2 cases. X minus 78 equals a +2. And x minus 78 equals a -2. So we're going to add 78. So one temperature is going to be 80 degrees Fahrenheit. Make sure you put the unit. The other temperature is going to be x equals 76 degrees Fahrenheit. So those are the 2 answers for part B. So if we were at 78 and increased 2 degrees, we're at 80 degrees. If we're at 78 and we decrease by 2 degrees, we're at 76. Part C, in your aquarium, if your aquarium's thermometer is accurate within plus or minus 1 degrees, what should the temperature of the water be to ensure that it reaches the minimum temperature? So our minimum, remember, that was 76. So if my tank is within 1, the temperature of the tank is only 77. Because if I increase 1, I'm at 78, which is still the normal temperature. But if I decrease 1, I'm at 76. If I tried 75, yeah, if you increase 1, you're to 76. But if you decrease, you'd be at 75, which isn't the minimum. So think about, we got to get our temperature checks when we walk in the building for COVID. If you're at 100.4, sorry, go back home. But if you are below that, you can stay in school, but if you're above that, you can't. So kind of the same idea. All right, so that's it. So there is a Google form that will ask you for some common mistakes. Remember, I said that some students think that absolute value means the opposite, which is not true. It means the distance from 0, which is always positive. And on the equation, some students forget about case 2. They only do case 1.